Good afternoon or good evening. Welcome along to the final session of the day. Though if you're Irish, you're probably just going to start off on another session after this and have a few drinks. Hopefully you're all going to stick around for the end of this. I realize there's a lot of parties tonight, and I am the only thing between you and alcohol. I only have about 3 hours of content, so hopefully the bars will do what we call a lock-in and keep you in overnight so you can make up for it. Welcome along to this session. It's called The Hidden Treasures of Windows Server 2012 R2 Hyper-V, quite a long title. My name is Aidan Finn, and as you can guess, I like long titles. I am a Hyper-V MVP. I'm one of about 70 odd. There's a slew more of my colleagues here in the front row and around about as well if you have any Hyper-V questions. I am the technical sales lead with a technology distributor based in Dublin, Ireland called MicroWarehouse, where I work with these technologies and I evangelize these technologies to Microsoft partners who operate primarily in the small medium enterprise space, but also with large enterprises. But my focus tends to be on small medium enterprises or SMEs. I blog on aidanfinn.com, where every now and then I will write a technology post and sometimes an opinion post. And I'm the contributing editor on Microsoft Virtualization for the Petri IT knowledge base. I've written a few books with some of my MVP colleagues and Microsoft colleagues over the years. And once in a while, I will tweet as @Joe_Elway, but it's a rare occasion. This session, I am going to be focusing on the Hyper-V that you can deploy right now. There are lots of really good sessions on Hyper-V and related technologies this week. If you want to learn more about Windows Server 2016 and some of the very cool things it can do, I'll have some links to some interesting sessions that you can check out this week or download when you get home. But I want to focus on what you can do right now. And I'm focusing on the features that tend not to get the publicity, that tend not to be talked about in a very obvious way. Sometimes they're alluded to with big announcements, but they're not necessarily talked about in great detail. So I'm going to be spanning various different things in the SME space and the large enterprise space, so don't feel like you're being left out. I'm going to be covering virtual machines, networking, administration, and failover clustering. And this session is going to contain just a little bit of PowerShell. So if you're allergic to PowerShell, doors that way. Hopefully I'll convince you to change your mind about that. Just out of curiosity, how many of you here are using PowerShell on a fairly regular basis? Jeffrey Snover must love you guys. So you're atypical because you come to events like this, you hear the message and everything. Unfortunately, you guys probably realize that it's a bit different out in the real world. PowerShell isn't necessarily adopted to the same levels. So I'm going to be preaching to the choir here, it looks like. But hopefully some folks at home will see some things and realize that maybe they should learn a little bit of PowerShell. Certainly, I'm a latecomer to it. I only came along with PowerShell in Windows Server 2012. And like most scripters, I script using copy and paste. And a lot of inspiration by other people. So let's start talking about one of these grand announcements Microsoft made a few years ago when they launched Windows Server 2012 Hyper-V, which was they were going to be able to support virtual machines with a terabyte of RAM and 64 virtual processors. What I was going to say right here was, I've never seen a physical piece of hardware in person that has a terabyte of RAM, but as of half an hour ago, I would be a liar, because I actually saw one of those in a 2U cluster in a box down in the expo hall. But to be quite honest, I doubt I will ever deploy a host like that in the next 5 years. I certainly am not going to deploy a virtual machine with 64 virtual processors and a terabyte of RAM. Is there anyone in here who would? As a host, what about a virtual machine? Anyone got an application server that size? Nobody? Okay, that's the normal answer. And most people, when they see this, they go, oh, those are Top Gear numbers. That stuff is totally irrelevant to me. That's like saying some car has so many brake horsepower and can do 300 miles per hour. I'll never get to do that. That's just theoretical. And you know what? For most of us, it is. But if you're in a small, medium enterprise or even large enterprise space, these sort of figures give you confidence that you can deploy a virtual machine and that thing can scale. And it can grow. And there's a big line you're hearing a lot this week, which is IT operating at the speed of business and not the other way around, which is what it always has been. Now we can deploy infrastructure and applications and services on that infrastructure that can scale. So those physical servers that we still hang on to, as long as there's not particular peripheral or support limitations with our applications, we can deploy them as virtual machines. One of the things Microsoft had to deal with, and every operating system and hypervisor out there has to deal with, is non-uniform memory access. If you take your typical host or application server, it might be a half-height blade, it might be a 1U or a 2U server, it's got a pair of processors, and on the motherboard, the memory banks are split into two. And you see that on the instructions on the inside of the case. Each processor has a direct bus connection to half the memory DIMMs on the motherboard. And you have specific instructions about how you lay out the DIMMs to get optimum performance for your processors. This is NUMA, non-uniform memory access. Each processor has a direct bus connection to half the memory on this two-socket host or two-socket application server. And when an operating system, such as Windows or Linux, or a hypervisor, such as Hyper-V, is scheduling a process and assigning memory, it's going to do its best to make sure that the process and the memory come from the same NUMA node. If, however, there's a constraint in memory, they're going to have to access memory from the other NUMA node. And this is going across a back channel. Basically, it's going from one processor through another processor and through that other processor's bus to its memory. So it's a bit of a route instead of having a direct bus connection. And that reduces the performance of that process. If that process is a virtual machine, it reduces the performance of that virtual machine. And this is something Microsoft had to deal with when they said, we're going to allow virtual machines that have more than 4 virtual processors and more than 64 gig of RAM. They were guaranteed they were going to do something called NUMA spanning, where they were accessing memory from other NUMA nodes. So what they gave us in Windows Server 2012 was guest-aware NUMA, or virtual NUMA nodes. When a virtual machine boots up, Hyper-V will make that virtual machine's virtual hardware aware of the physical NUMA architecture that it's running on. And therefore, the guest OS, be it Windows or Linux, is aware of that virtual NUMA architecture. This means that the guest OS can schedule processes and allocate memory according to the physical architecture of the motherboard that's beneath it. And NUMA-aware applications such as SQL Server or Oracle are able to do the same thing. So that's how Microsoft are saying, or are able to say, yeah, deploy these big OLTP workloads and get near physical performance. It's features like this and the performance traits of the storage subsystem and the network subsystem as well. These NUMA nodes are static. So once you boot a virtual machine, Hyper-V reveals the physical NUMA architecture the virtual machine is running on, but doesn't change it. So if we move a virtual machine from a host that has large NUMA nodes to a host that has small NUMA nodes, then we'll have an issue. There's an overlaying, and it's called splitting. So that virtual machine moves from a host with large NUMA nodes to one that has small NUMA nodes, and it still has that static architecture it had when it booted up on the larger host. And this will reduce the performance of that virtual machine. We have a setting called NUMA spanning. It's enabled by default in the host settings, which you can find in Hyper-V Manager, and you can access through PowerShell as well. You can disable this setting if you want. Typically, it's left on. Most people aren't even aware of what it does. If you do disable it, you get some benefits. It forces the virtual machines, when they boot up, to be contained within the NUMA architecture of the host. So they can't span those NUMA nodes. Now, that's going to limit the scalability of your virtual machines, potentially. But on the good side, it's going to have consistent performance. The virtual machine will have consistent performance between reboots. It'll always have the same virtual NUMA architecture. The bad side is you won't be able to start a virtual machine that it has to span NUMA nodes to meet its startup amount of memory. And if you do try to live migrate that virtual machine to another host that has NUMA spanning disabled and the NUMA architecture is smaller, then that virtual machine will fail to live migrate. So we lose that great flexibility feature of Hyper-V. NUMA, or virtual NUMA, or guest-aware NUMA, is one memory optimization technique that we have. What it does is it optimizes the selection of memory. Dynamic memory has been with us since 2008 or 2 Service Pack 1, and that optimizes how much memory we allocate to a virtual machine. And it's a very dynamic feature, as the name suggests. Its dynamic nature versus guest-aware NUMA's static nature are incompatible. So when we enable dynamic memory in the settings of a virtual machine, we lose guest-aware NUMA. So we have to decide, what are we going to do? And this is done on a per virtual machine basis. Are we going to enable dynamic memory and reduce the number of virtual machines that we're going to have on a host? Or are we going to leave our virtual machines with dynamic memory enabled and increase the number of virtual machines on the host? And as a result, enabling dynamic memory reduces the peak performance of that virtual machine. The vast majority of virtual machines, assuming the operating system and the applications that are running in it, will probably be configured with dynamic memory because we can get more of those virtual machines on there. But you're going to have some virtual machines that do span a NUMA node, be it the amount of memory they're consuming or the number of virtual processors they're assigned. They're going to exceed that NUMA arc or single NUMA node, so they're going to span NUMA nodes. We'll want guest-aware NUMA enabled for those virtual machines when they're running at peak levels. So let's have a look at this in action. My demo lab is running in Dublin, Ireland. It's a big rig with lots of nice networking. We are going over the same networking that you may have noticed that other people are having issues with today. So hopefully, the first of the 13 demos that I'm going to show you today will actually work okay. So what I'm doing is I'm running PowerShell scripts for these demos, and I'll explain why later. And I'm going to first off work with this virtual machine here called NUMA. You can see in Hyper-V Manager. What I'll do is I'll show you the configuration of my host. It is a 1U Hyper-V host, very typical of what you're going to find in the vast majority of deployments. Got a pair of processors, it's got a nice chunk of RAM. It's only got 64 gigs of RAM. That's a nice chunk to me. For most of you, that's going to be small. You can see there are 2 NUMA nodes. Each NUMA node consists of a 6-core processor with hyperthreading enabled, giving us 12 logical processors and 32 gig of RAM. If we check out my virtual machine called NUMA, we can see that that virtual machine has 24 virtual processors. I said, why not? Give it 24 virtual processors. And it has 8 gig of RAM. Dynamic memory is enabled. So it's got 8 gig of maximum RAM. With dynamic memory enabled, we lose guest-aware NUMA. This virtual machine is spanning 2 NUMA nodes because it's got 24 logical processors. So it's guaranteed to be spanning 2 NUMA nodes. However, we can see that the virtual machine is not aligned, and it's only got 1 virtual NUMA node. Now, what if I want this virtual machine to run at peak physical performance? I'll need to disable dynamic memory. So I'll shut down the virtual machine, set it up with static RAM, and now I can see that the virtual machine has 2 virtual NUMA nodes and dynamic memory is disabled. So simple decision to make. Rule of thumb, do I want peak physical performance for machines that are spanning NUMA nodes? Then run with static memory. Otherwise, go with dynamic memory to get more of those kinds of virtual machines on your host. We need to be more flexible. We need to be able to deploy things more rapidly. We're getting to a new world where we're getting updates more frequently from Microsoft. You heard yesterday that System Center is delivering feature updates every quarter with their update roll-ups. We know that that sort of thing is coming to Windows as well through the flighting mechanisms. And we need to be able to test these updates on our production systems. Now, I don't know about you guys, but I tend not to like testing updates on production systems to see what happens. But you know what? Microsoft did make it possible for us to test these updates, and our operating system updates, our application updates, our rollback plans, our backups and restores, they made it possible to do that with our production systems through a cloning mechanism of virtual machines. So I can take a running virtual machine and I can export it without shutting down that virtual machine. And then I can import those export files to create a clone of that virtual machine, probably running on an isolated test network, and that allows me to do all my testing that I need to do to see what will happen with my operating system upgrades, my application upgrades, my rollback plans, and all that good stuff. If you're working in a DevOps environment, you probably are living with checkpoints, formerly known as Hyper-V snapshots. Your testers, your developers, might like to see what happens when they do some stress testing or diagnostics or whatever on an old version of a virtual machine. So they can export a checkpoint and then import that checkpoint to fire up a clone of a virtual machine as it was at some point in the past. And this gives the operators, the DevOps guys, a lot of flexibility, the ability to really work with a production system without impacting any production services. So, going to run this script. And here we're working with the NUMA virtual machine once again, and we can see the virtual machine is operating normally. I'm going to export that virtual machine. That's exported the virtual machine's files onto D exports, and we can see those files right there. So what we'll do is check to see that the virtual machine is still okay. We can see the virtual machine's been running for about 2.5 minutes, so we haven't had to shut down the virtual machine to do the export. What I'm going to do now is create a checkpoint of that virtual machine, formerly known as a Hyper-V snapshot. There is the checkpoint. Now I'm going to create an export of that checkpoint. And what that's actually going to do is a kind of a live merge process to create an export of the virtual machine. It's a very clever process that's taking advantage of the ability to do live merges of checkpoints. Now I have those files, and I can import that checkpoint, that exported checkpoint, to create a clone of my virtual machine, which is now running there. So now I have an identical copy of a production system with its guest operating system, its settings, its applications, and its data. I can bring that up on an isolated network, and I can do all sorts of bad things to my production system and see what happens. And I can document the entire process, and then when I come to my maintenance window, I can implement the documented process confident that everything I do should be completely repeatable. And the boss should like that, and if I'm doing it at 3 o'clock on a Saturday morning, my significant other should also like it, because I'll be home a lot quicker. We're in the era of cloud computing. There's a lot of debate about what a cloud is. The US National Institute of Standards and Technology has a widely accepted definition of a cloud. And one of those traits is that a cloud is measured. And we can see this on clouds like Azure, where if you deploy something, you're paying by the hour for the virtual machine and per gigabyte for storage and per gigabyte for egress data and stuff like that. We can do that in Hyper-V as well using resource metering. So we can record granular data by default on an hourly basis, and that's changeable, for processor usage, memory usage, network usage, and disk usage. Now, you may not be in a sort of organization that is going to do chargeback reporting, where you charge other departments for their utilization of your central cloud or Hyper-V infrastructure. But you might want to do show-back reporting, where you can show those various internal customers how much they're using from IT and what value you're providing to the business. This data is stored with the virtual machine, so when we live migrate the virtual machine, the data moves with the virtual machine. There's no SQL database required for this. We can retrieve that data using PowerShell, or it can be retrieved by management systems such as System Center. It's all managed using PowerShell and configured using PowerShell. We can enable this on a per VM basis, and of course with PowerShell, it's very easy to scale that out to all the virtual machines on a host or a cluster. And then we can use Measure VM to pull back that data. Again, very easy to do that on a per VM, per host, or per cluster basis using PowerShell. We can do some interesting things with that through PowerShell. So we might want to find the top 3 utilizers of processor, and then have a talk with those particular people and invite them to go into a higher price band for virtual machines. Or we might dive into the network reporting to see how much traffic is actually going to a particular subnet, or even leaving the company and going to the internet, and charge those people for that sort of bandwidth. And you can dive really deep in there as well. And that takes advantage of some of the Portacle stuff that we'll be talking about later. So we'll have a look at that now. So, resource metering. So I'm going to enable resource metering on a virtual machine. And as I said, you can do this on selected virtual machines or all virtual machines. You might do this just out of curiosity to diagnose what's going on with a virtual machine. And it's a single command that I've run, get VM, name of virtual machine, pipe that into enable VM resource metering. And then I did some stress testing to just get some data in there. Now I'm going to check the usage data by using measure VM. And I can see the average CPU utilization was 10 megahertz. Average RAM utilization was 2,376 megs. It spiked at the same amount. Total disk is 60 gigs, thereabouts. And inbound network traffic was 173 megs. Now, I can dive into the networking traffic and see how that 173 megs is broken down. So there might be one of those that I do charge for, or I want to do showback reporting for, or maybe I want to get some particular developer into trouble because they've made my life difficult, so I can show the boss what they're up to. Maybe they're doing some, interesting downloads. So we can really dive in there and get some interesting information. One of the grand claims that we've seen Microsoft make, and we've seen some of Microsoft's storage partners make, is that they can achieve 1 million 4K IOPS from inside of a Hyper-V virtual machine. Now, 1 million IOPS, that's a lot of IOPS. I have never achieved 1 million IOPS. I've got some nice storage stuff back at work, and I've never hit that. And I know some people have deployed some big systems, and they've never hit 1 million IOPS. And that's because, well, maybe they don't have the right hardware, because very often this is all SSD storage that's being used, and some interesting RDMA networking. But there's also some tweaks that are being done in Hyper-V that aren't widely known about. One of the features that they're taking advantage of is VM bus multi-channel, also known as storage, or storage NUMA I/O. When the virtual SCSI controller, where your data disks are normally attached in your Hyper-V virtual machine, when that's sending an interrupt to the processors or the virtual processors within the guest OS, those interrupts are going to core 0, and just core 0. So that limits the amount of bandwidth that can be processed between the virtual machine and the storage subsystem. When we add more channels, we can increase the amount of bandwidth and therefore achieve more IOPS. By default, a virtual machine has a set number of channels and a maximum number of channels, and that's dependent on the number of virtual processors in the guest OS. So a virtual machine with 2 virtual processors has one of these channels and has a maximum of 1. And all the way up to the other end of the scale, a virtual machine that has 64 virtual processors has 4 of those channels by default and kind of a maximum of 16. We can edit the registry in the guest OS to change the number of channels up to the maximum. You'll first need to get the device ID and the instance ID of the virtual SCSI controller, and then browse to that location in the registry, increase the channel count number, and then do the usual reboot, and then you can start doing some stress testing. So on the slides, I do have a link to a particular white paper by a Microsoft hardware partner, and they did the usual claim of 1 million IOPS from inside of a Hyper-V virtual machine, and this is how they did it. First, they created a virtual machine that was stored on a scale-out file server that had all flash storage, all SSD storage. It was connected to using SMB3, so SMB Direct, SMB multi-channel. They configured the virtual machine with a single SCSI controller. That SCSI controller had 16 data disks. Each one was a fixed VHDX of 127 gigs in size, and then striped or used storage spaces or something like that with those disks. They increased the storage channels from the default of 1 to 4. Then they disabled something called a Hyper-V I/O balancer on the host. Hands up if you've heard of the Hyper-V I/O balancer. That's about 3 times more than I expected. The Hyper-V I/O balancer, you can learn about that if you read the Windows Server 2012 R2 Storage and Performance Tuning Guide. What it tries to do is ensure that every virtual hard disk gets a fair share of storage bandwidth. It's measuring how much activity is going on, and if you're a Trekkie or you're a physicist, you know anything that's measured is affected. So if you want peak performance, you disable those measurements. So that's what they did. They disabled that on the host with that registry setting. Then in the guest OS of the virtual machine, they ran Iometer with 16 threads targeting the 16 virtual hard disks. and they spike that storage, and that's how they hit 1 million 4K IOPS. So if you want to stress test a nice new scale-out file server or storage spaces deployment from within a virtual machine, this is how you're going to do it. Now, while we're talking about virtual hard disk performance, typically we don't want to spike our physical subsystem. We want to guarantee a certain level of performance for our virtual machines and our services, and we want to cap virtual machines from over-flooding the system and preventing everyone else from having a share of the storage subsystem. And this is where Storage QoS comes in. Now, I'd recommend that you go to a session this week on Distributed Storage QoS in Windows Server 2016 on the scale-out file server. It's a very nice new feature. However, we have Storage QoS in Windows Server 2012 R2. It's a very simple mechanism compared to what's in 2016. It allows us to implement QoS in the virtual machine settings on a per virtual hard disk basis. We have two settings available to us. Maximum IOPS, which is a very simple one to understand. This is the maximum amount of IOPS we are going to allow that virtual hard disk to have. And it's automatically enforced. So that's nice and simple once we understand what IOPS are and how much our services need. The other one, though, is a bit more complicated. And I have to thank Didier Van Hooy, a.k.a. at Working Hard in IT, for his help in documenting the WMI side of this. Minimum IOPS is not automatically enforced. It does not give a virtual hard disk an SLA. It's purely an informational service. Now, hands up if you think that sort of thing would be an event viewer. Okay, a couple of brave people. And Microsoft thought, no, we can't put it in there because we'll flood event viewer. So what they do is they record the alarm in WMI, but it's only there while the condition exists. And even more interestingly, it's only recorded soon after the condition starts. About a minute from my testing. In fact, exactly a minute in my testing. So this is how you can find out where the alarms are generated. Go into WBM test, connect to the root virtualization v2 namespace, click query, then do a select star from MSVM logical disks, browse to the particular virtual hard disk. You'll need to know the ID of that virtual hard disk. And you can do a PowerShell query to find out that disk ID. It's nice and simple, isn't it? Then double-click on that. You'll see operational status. Select that. Click on Show MOF. And then look for operational status. A healthy status is 2. However, if that status, and it's an array value, if that array has a value of 3 and 32788 in its first two cells, then that particular virtual hard disk has not been able to achieve the minimum number of IOPS that you wanted that disk to have. So I presume you're all going to hire someone who's actually going to do that query on virtual hard disks to make sure that everyone's getting a set level of performance, right? No? Dang. What you can do is you can use PowerShell. And this is the PowerShell that you can use to do everything I just did with all those clicks. This will scan all your disks. So you can run this on an intermittent basis from whatever monitoring system you use. And it will scan the disks in WMI and alert you if there is an issue. And we can see this in action in a little demonstration. First, we'll have a look at the simple one. We'll look at max IOPS. So max IOPS, we're going to work with a virtual machine that has a pair of data disks on the SCSI controller. And I'm running SQL.io within that guest OS. I know I should be running disk speed, but I know how to do SQL.io. I'm going to stress test those disks, and I'm going to use perfmon on the host to look at that data. So we can see that both those disks, there is actually a red line, and that's overlaid over a green line. Those disks are being stressed. I'm pushing a lot of IOPS through there. What I'm going to do now is limit one of those disks to 100 IOPS. And what you should see is a green line plummeting. That disk now is limited to 100 IOPS. So if the owner of that virtual machine was abusing the storage subsystem, or if I wanted to price band my storage, I can implement this sort of rule, and that person has no control over it. That tenant has to do what I've configured. Now I can uncap the disk, set the maximum IOPS to 0, and now they're able to spike the system again. And that's maximum IOPS in action. Now we look at minimum IOPS. Once again, we're going to stress test the same virtual machine. And we can see it's getting stressed nicely there. Now, I'm going to set minimum IOPS of 1 million on each of those virtual hard disks. I'm not going to achieve 1 million IOPS. I have a loop running. Every 5 seconds, it's doing that WMI query that you just saw on the PowerShell slide. And it's checking. And 60 seconds after I set those rules, there's going to be an alarm recorded in WMI. And then when the condition ends, that alarm will disappear. So that's why I'm running it in a loop. Pick it up when it happens. I don't have a history of what's going on. I'll keep that history in my monitoring system. So hopefully, 35 seconds. What's the over-under? 40 seconds. 45. Oh, doing live demos like this is always nerve-wracking. 55, come on, 60, 60, come on. You're going to see 60, and then it's going to appear. I know it, I know it, I know it. Yes! So we weren't able to achieve 1 million IOPS with each of those virtual hard disks. So we got the alert soon after the condition started. And once the condition goes away, that history's gone. But I'm picking up that and I'm storing it in my monitoring system. Hopefully my monitoring system has a nice data warehouse where I can pick up all those alarms and I can spot trends and I can start tweaking things and dealing with the issues. While we're stress testing and doing QoS, let's start talking about bandwidth. We want to be able to, networking and storage for me are the two most important things in virtualization. When you get those things right, everything else in virtualization is easy. That's the difficult bit, getting the storage working and performing right, and getting the networking performing right and being stable. Once we've done that, everything else is just easy street. We have the ability to implement some very interesting architecture since Windows Server 2012, where we can converge all the various networks of a Hyper-V host or a clustered Hyper-V host into fewer, higher capacity networks. That makes 10 gig or faster networking more affordable and achievable for businesses, be they small, medium enterprise or huge hosting companies with rack after rack of compute and storage and networking. And we can do all this, and we can guarantee a minimum level of performance for each of those virtual networks using QoS that's implemented using the features of Windows Server. We don't need those expensive hardware appliances that you often find in the back of a Blade chassis. That's great. That stuff's heavily documented. What I want to talk about is implementing QoS for virtual NICs in our virtual machines. And we can do this using PowerShell, where we can implement rules that are absolute or weight-based. So absolute is where we set a certain amount of megs per second or gigs per second. And weight-based is where we say you can have a certain share of the overall bandwidth that's available through the virtual switch. Typically, Microsoft will recommend you go weight-based. However, absolute can be easy to visualize. We understand megs per second and gigs per second. And it's a nice way to go if you have a fairly consistent deployment across your entire compute space. We can have a look at VM bandwidth now. So switch over to the demos and run. So I'm going to stress test the network into a virtual machine. I'm using nttcp.exe to do the stress test. Again, my friend Didier helped out with some of the configurations for that test, so thank you, Didier. We are running a test into that virtual machine, and what I'm going to do is limit that virtual machine to 100 megs. So we can see what's going on right now. Let's limit that machine to 100 megs. And now we see we're getting a much lower amount of traffic into that virtual machine. I can use this in a couple of ways. Maybe there's some machine or some service that's gone crazy and is absolutely hammering the switches on my core network. Or maybe I want to start price banding the people on my network. If I'm working in a hosting environment, I can say, okay, these guys are going to be limited. I'll tell you another way I've used this. Me as a person who does demonstrations and stuff, I want to be able to demonstrate technologies like branch cache. I need to be able to simulate limited amounts of bandwidth between two locations. I can use this functionality to limit the bandwidth of a virtual machine, so I can demonstrate the advantages of enterprise features of Windows. And I can run this command line again, and instead of going 100 megs, I've set it to 0 megs, and that lifts the cap on that virtual NIC, and now I can continue to push true traffic into that virtual machine. How many of you here work with virtual machines that reside on isolated networks? VLANs, network virtualization, private virtual switches? Good few of you. How many of you have ever been asked to copy a service pack into that machine, or a patch, or an installer? Good few hands. Typically, that involves doing interesting things like using enhanced session mode, which allows you to copy files through the VM bus using remote FX channels. Maybe you'll do something mad like open up Internet Explorer, remove the security features, and download the file directly onto the virtual machine's guest OS and hope for the best if somebody isn't spear phishing or any of these other weird and wonderful attacks that are out there that can harm us. What you can do is use out-of-band file copy, which allows you to copy a file from your PC or your administrative station into the guest OS and onto the virtual hard disk using the integration services. In particular, we're using a service that's disabled by default called a guest service. And the data travels through the VM bus of the hypervisor. You do not need network connectivity to get this file or these files into that virtual machine. This is a really useful feature if you are working in those environments where there are isolated virtual machines like PKI root servers and stuff like that. Or you're working with a DMZ, for example. We can enable the VM integration service, the guest service, and then we can use copy VM file to transfer the file into the location of choice within that guest OS. And then afterwards clean up by disabling that service and making sure that that channel isn't available to anyone else in our environment. So we'll switch over, we'll have a look at out-of-band file copy in operation. So we'll run that script. And we'll open up a browser on my Hyper-V host. Do as I say, not as I do. And there's a nice post by Microsoft. Let's copy some text off of that. Store that in a Word document that's going to be saved on my host. Save. Close the document. Close Internet Explorer. Now I'm going to enable that guest service using Enable VM Integration Service. Now, I'm going to copy the file using copy VM file into the C drive of that virtual machine. Clean up by disabling the integration service. Now let's log into the virtual machine. We can see enhanced session mode in action there. So I'm being forced to log in even if I had a previous login, so I have increased security, and it supports USB for smart card logins and stuff like that. And it has copy-paste, which was one of those big asks for a long time in Hyper-V. So let's log in. There's a file called copy file. Let's look at that. And that is the text that I just pasted in. So that's how I can get my SQL service packs or my update rollups for System Center into my virtual machines without having to copy the files over a network. So that will be a nice security feature. Okay. Next, we'll move on to networking, one of those foundations of Hyper-V. Everyone wants to have more uptime on their virtual machines. Hands up if you don't want to have more uptime on your virtual machines. There's always two. The crazy Swiss. We want to improve the uptime of our services. And typically when we start talking about uptime, we start talking about high availability and failover clustering, which we'll implement with Hyper-V hosts. So if one of those hosts fails, virtual machines will fail over to another node, automatically boot up, and our services continue to run. But what if the virtual switch has a complete physical link failure on one of those hosts? Will that failover action happen? Well, if you're running a fully converged deployment of a Hyper-V host? Yeah, it will, because all your networking is going through those physical links. The NetFT driver that sends the cluster heartbeat won't have a connection to go through. So yeah, that host will time out and there'll be a failover. But what if you're not fully converged? What if you're running a more traditional Hyper-V networking deployment? Or you're only partially converged? Then NetFT still has a path. So the virtual machines are running on the virtual switch, but have lost their uplink. Someone's pulled both the network cables from a NIC team or something like that, or there's been a switch failure. And your virtual machines are no longer accessible to anyone. They're still running. They're not accessible. The host is still responding to a heartbeat, so there's no failover. So this is why Microsoft gave us protected networks. It's on by default, and it's configured in the settings of your NIC in your virtual machine settings in Hyper-V Manager or Failover Cluster Manager. As I said, it's on by default. And if the cluster detects a complete link failure on the uplink of the virtual switch, it will initiate a live migration of those virtual machines to another node in the cluster that has an identical network configuration. So the virtual machine stays running and continues to operate and offer services. About a minute later, it doesn't do it straight away because it allows for transient failures. It'll move the virtual machine over to another host in that cluster after about a minute, and then consumers of the services of that virtual machine will have access to those services once again. I demonstrate that, but it doesn't work by disabling NICs. It only works with complete link failure. And I had a bit of a timing issue trying to get some of my colleagues back in Ireland to start pulling out cables on command. So I figured we'd just move on to another subject. And that's network security. Everyone wants better network security. In Windows Server 2012, we got portacles. The ability to implement filters that are applied by the virtual switch. Basically, they're firewall rules, but they're a very simple form of firewall rule. As I said, they're implemented by the virtual switch. So the guest OS administrator has no control over this. They can do whatever they want with the Windows firewall or Linux operating system firewalls, but they can't override what's implemented by the virtual switch. The Hyper-V administrator can create rules in Windows Server 2012 that are either inbound or outbound and are based on either the network or machine IP address, source or destination, or the MAC address of a source or destination virtual machine. We can deny traffic, allow traffic, or meter traffic. This goes back to resource metering, which we talked about earlier. There is a very simple system, and if you had very simple security requirements, these would work. So if we wanted to allow traffic between one machine and another machine, we could allow all traffic. Or if we wanted to block traffic between a network and another virtual machine, we could block all traffic. But we couldn't do more complicated things based on protocols. And this is where extended portacles in Windows Server 2012 R2 come in. Now we get stateful inspection. So we'll allow a machine to respond to a particular machine or another machine. We can implement rules that are based on protocol, be it TCP, UDP, or numeric, and we can implement port numbers. So this is all kind of like firewall rules that you're probably doing already on your physical appliances. We can build up a layering of rules. So for example, with the first commandlet there, with add VM network adapter extended ACL, I can implement a rule with a weight of 1 that blocks all inbound traffic. So no traffic can get into that virtual machine. And then I can implement a higher weight rule that's an override and allows inbound TCP 80 traffic. So now I can access web services that are running on that virtual machine, but I can't access anything else. And this allows Hyper-V administrators to implement corporate security policies that say only allow necessary traffic into our application servers, block everything else. We can enable stateful inspection as well. So if a machine is responding, we can allow that traffic, but if it's a source of a stream of traffic, we'll block it. So let's have a look at that in action. We'll run portacles. And what I'm doing here is I have a virtual machine that is running IIS, and my guest OS administrator, one of those tricky developer types, has decided to lower the Windows firewall because it made his or her life a lot easier. And we love that as IT pros. Security auditors are wrecking our heads and saying, stop this, please. Otherwise, you're going to keep hearing us from every day. So I'm going to block all traffic into that virtual machine. So Internet Explorer is closing. Let's open it up again. Now I'm not able to access the web services on that machine. So that'll treat or show that pesky developer I'm really mean business, and they better comply with corporate rules from now on. We can see pings are blocked in there as well, and Internet Explorer is timed out. So what I'm going to do now is, and we can see the rule that I applied there, it's the one from the slide. I'm going to apply a second rule to that virtual NIC and be applied by the virtual switch. So now I'm allowing TCP port 80 inbound, and it's going to override the original rule. Now I'm able to access the web services running on that virtual machine, but everything else is blocked. So no matter what the guest OS administrator does, they cannot override that. All they can do is block more traffic, which the security guys are probably going to be even happier with, let's face it. So that's extended port ACLs, built-in firewalling within the virtual switch. We talked about deploying bigger virtual machines and getting better performance with memory and processor, but we also want to be able to push more traffic in. If we've done some of that converged networking stuff, we've probably invested in 10 gig or faster networking. And probably the first thing you're going to do, if you're a nerd like me, is you're going to run a stress test networking tool to see how much traffic you can get into that virtual machine. And you're going to be really disappointed when you're getting about 4.5 to 6.5 gigabits per second. I just bought 10 gig networking or 40 gig networking. Why am I not getting that? Why? What am I doing wrong? It's Microsoft. It must be. No. It's the way that the hardware works. So if you had a physical server and you're pushing traffic into a 10 gig NIC, interrupts are sent to core 0. And core 0 by default, and only core 0. And your bandwidth your inbound bandwidth to that physical machine is limited by the capability of core 0 and its ability to handle those interrupts. In Windows Server 2012, we got receive side scaling, or RSS. So we could allow the NIC on that physical machine to send interrupts to more than core 0. And we could scale out our inbound bandwidth, and then we could get that 40 gig, or 10 gig, or 56 gig, or whatever it is we had. In Windows Server 2012 or 2, we got virtual receive side scaling, or VRSS. So if we have a virtual switch that's connected to an uplink or physical NICs that have VMQ enabled, VMQ is the virtualization cousin of receive side scaling. If we have that enabled, and it's nice and stable, we can log into the guest OS of our virtual machine that needs lots of inbound bandwidth, go into Control Panel, Network Settings, open up the properties of your NIC, go to Configuration, and enable receive side scaling. Change it from no to yes. And now, after that NIC resets itself, which takes a couple of seconds, you'll be able to push through all the bandwidth that you're able to supply. And your virtual machines, virtual processors can handle. So typically you're talking about a virtual machine that has lots of virtual processors. This is a very useful feature if you are deploying big workloads that do need to be able to handle a lot of traffic. So I'm going to work with 2 virtual machines here in this test. Again, we're going to be using nttcp.exe. There's a lot of T's in there. We're going to stress test the first virtual machine. Both these virtual machines are identical. They've got 8 virtual processors and 4 gig of RAM, and they're connected to the same 10 gig networking. We're pushing through data to this first virtual machine that does not have receive side scaling enabled in the guest OS. And we'll see in a few seconds how much bandwidth and how much data I'm able to get through to this virtual machine. I'm expecting, it's come in at 924 megs per second. We can see that right there. So what we're going to do is try that against a second machine that I've enabled receive side scaling in the network settings. So we can see the commandlet that would have been used there. Fire the same test. Let's have a look at perfmon. And we should see this is going to get roughly double the bandwidth. Same host, same virtual switch, same 10 gig networking. All I've done is changed or enabled receive side scaling in the guest OS of that virtual machine. And it's pushing through quite a bit of data. So let's see what the result is. It should finish right around now. So the last one was 900 meg per second roughly. This one has done 1,710 megs per second. Same spec virtual machine, just turned on receive-side scaling in the properties of the guest OS. And now I can really take advantage of that high-speed bandwidth that converged networking allows me to afford. We've seen a number of you already raise your hands to say you're working with virtual machines that are in isolated networks. And you've probably experienced some of the fun that you may have if you're trying to do network diagnostics. We all know which tool we start with when we're doing network diagnostics. It's ping. We're sending ICMP packets from an administrative machine or some other virtual machine to an application server or some workload server that's having issues. But if you're working with virtual machines in isolated networks, and if you don't have administrative rights in those virtual machines, or you're not supposed to log into those virtual machines because all that stuff's audited and you don't have permission or whatever, then ping just is not going to work. And this is where we start looking at a command called test VM network adapter. Let's compare test VM network adapter with ping. Ping allows us to send an ICMP packet from a physical server, such as a host, or an administrative PC, that's on the same network as some virtual machine that we're trying to diagnose. And that's great. That works. Packet goes out, we get a response back, and we're told if it's connected or not, and we're told what the latency is like. It's a great start to all our network diagnostics until we don't have connectivity to those virtual machines that are having the issues. So this is where we dump ping and we go with test VM network adapter. And we can use this when we're working with virtual machines on private virtual switches, network virtualization, so software-defined networking, or we're dealing with private virtual switches or VLANs or whatever. So test VM network adapter is going to inject an ICMP packet into the NIC of a selected source virtual machine. That packet will go across the virtual switch over to the destination virtual machine, and then a response will come back. And that's reported to test VM network adapter, and then the results are displayed on screen. That's the commandlet right there. It's quite a wordy commandlet. We need to specify the sender IP address, so the source virtual machine, the destination virtual machine, and the MAC address of the source virtual machine, if I remember correctly. And that allows us to test those isolated networks. So we can see this in action. Here I have those two virtual machines I was working with earlier in the stress testing, and I'm going to ping one of those virtual machines, and we can see that we are getting a response back less than 1 millisecond, so that's great. That's my traditional ping when I'm able to talk to a machine on the same network. What I'm going to do now is I'm going to take those virtual machines and I'm going to put them onto a private virtual switch. So I've lost connectivity to those machines from this physical box. I can no longer talk to them. I can prove that. Let's ping, and this should time out. So we have no response now. We had 100% loss. So I've got these nice secure virtual machines, and now the guest OS administrators are saying, I think there's network issues. Can you diagnose it? Well, they don't want to give me administrative credentials to log into those virtual machines. What am I to do? I can use test VM network adapter. So now I can inject an ICMP packet into a source machine, send it over to a destination machine without needing physical or virtual network connectivity, and without needing logon credentials for those virtual machines. All thanks to Hyper-V. So we can see we got a response back in less than 1 millisecond. So now I can pick up the phone or send a link message to that guest OS administrator and say, yeah, everything's fine. It must be your application or your code. So that's test VM network adapter. How many of you had heard of test VM network adapter before? Okay, about, I'd say 15% of the audience. Okay, failover clustering. Microsoft's high availability feature in Windows Server and how we make highly available virtual machines. We typically are deploying these sorts of environments into a data center where we have physical security. But thanks to hardware solutions like Cluster in a Box, and if you haven't heard about Cluster in a Box, there's plenty of them down in the expo hall, very cool hardware solutions that allow you to deploy an entire cluster or a Hyper-V cluster or production environment for a branch office or a business into a 2U or a 4U or a 5U enclosure. It's fully self-contained. We can deploy those out to branch offices or to remote locations, but the problem with that is we don't have physical security. And we start getting worried about having application data, domain controllers, and all that good stuff out in those locations. What if someone steals that hardware? What if they steal the disks? What if they just start copying stuff? What if we lose physical control of that? What if we're the military that's in a forward operating base and we get overrun? All our secrets, all our plans are gone. So this is where Microsoft would say use BitLocker. Now, we've had the ability to encrypt the D drive or some other non-CSV drive with BitLocker, where we're storing our virtual machines since Windows Server 2008 or 2. However, we now have the ability to encrypt the cluster shared volumes of a highly available failover cluster. So we can encrypt the virtual hard disks and the XML files of our virtual machines. So if we lose physical security over that hardware, well, that opposing force is no longer able to access the files and the data contained within those virtual machines. To enable BitLocker on CSVs, you are going to need Windows Server 2012 domain controllers or later, or Windows Server 2012 or later clustered hosts. And your CSV must be formatted with NTFS, not REFS. You can encrypt the cluster shared volume before you deploy virtual machines onto it or after. I would highly recommend you do it before because it's going to be a lot quicker. We do need to pause the CSV to encrypt it. So if you do have virtual machines on there already, it's going to take quite a long time to encrypt, so you're going to have virtual machines offline for quite a while. Now, you may ask, okay, that's encryption on the disk. Isn't that going to have some sort of performance impact? The answer is yes. But according to Microsoft, it's minimal. It shouldn't be a huge impact. If you are the sort of customer that is worried about physical security, well, security trumps peak performance. And let's face it, most virtual machines typically don't need, great levels of physical performance. So this is going to be a very useful solution when we are deploying solutions like Cluster in a Box units out in these pop-up branch offices or remote locations. There's a few slides of PowerShell for implementing this solution. First, we need to suspend the cluster shared volume, and then we're going to create a secure string that's going to be used to encrypt those volumes. First off, before I go anywhere like that, I do need to enable BitLocker using Add Windows feature on each of the nodes in the cluster. Then we protect the recovery password. We save that. We back it up. Then we grant the cluster name object of the cluster permissions to the CSV or CSVs. Then we resume the cluster shared volume, and we have ourselves an encrypted volume that we can start deploying virtual machines onto and be sure that they're encrypted and safe. Yes, minimal amount of performance impact, but we can sleep at night in case the opposing force overruns our forward operating basis. There's times when we need to be able to run scheduled tasks on our clusters. We might want to run these tasks on any particular node in the cluster at random, on a specific node that's running maybe a virtual machine. We want that task to follow the virtual machine. Or we want to run it on every node in the cluster. And we can do this using cluster scheduled tasks. So this gives us those 3 different scopes that allow us to schedule these tasks in advance and have them run either once off or on a regular basis. This is all managed using PowerShell. You can see the cluster scheduled tasks in Task Manager, but it's not supported to manage them through Task Manager. So it's a PowerShell operation only. We first implement an action, so we can store an action in a variable using new scheduled task action. So this could be some program we want to run. Then we create a trigger. This is our schedule. So we use new scheduled task trigger to specify when that action is going to run. Then we'll run register cluster scheduled task. And that will use the action and the trigger, and we'll specify the scope of execution. So in this case, we're going to run it on cluster wide, which is every node in the cluster at that trigger time. Then we can track the execution of that using getClusterScheduleTask against the particular cluster that we've aimed it against. And we can see this in action, where I'm going to run a very valuable task called Notepad on every node in my cluster. So, first we're going to create an action, and we'll store that in a variable called action. Then create a trigger to schedule that task. This is going to run, hopefully, in about 15-30 seconds. Then we register the cluster schedule task, and you can see that that task is called Notepad, and it's going to run cluster-wide. Now I'm running a loop in PowerShell to scan for Notepad running on each node in my cluster. And hopefully that will happen. Fingers crossed. So nothing to report yet. Nothing to report. Aha, Notepad is running. Here it is on demo host 1, and here it is on demo host 2. So that allows me to run some task. Maybe I need to prepare virtual machines in a certain way before a backup or before some sort of export that I do. Or maybe I actually even do a live export of virtual machines automatically every night. So I can clone them to do some specific automated recovery tests of my backup system. So this is a mechanism that is going to be very useful, and I'd be interested in hearing how you guys actually use it in the future. So next, we are going to look at virtual machine priority in a failover cluster. Not all virtual machines are made equal. Some virtual machines must be failed over before others. For example, we might fail over domain controllers before we fail over SQL servers, before we fail over application servers. Some virtual machines need resources and should override the resource requirements of other virtual machines. And we also might want to determine how we move virtual machines when we're performing regular maintenance on our hosts. And this is all possible using virtual machine priority. We can set the priority of our highly available virtual machines in failover clustering or using PowerShell. There are 4 options available to us. There's high, that has a numeric value of 3,000. There's medium, that has a numeric value of 2,000, and that's the default for all your virtual machines in a failover cluster. There's low, that has a numeric value of 1,000. And there's no auto start. These are the virtual machines that have little business value, and we don't want them to automatically start after they're failed over to a different node. Failover clustering will use these priorities to order the failover of these virtual machines, so the highs are failed over first, then the mediums, then the lows. We can also use this to start triggering quick migration instead of live migration when we pause a host. How many people would like to use quick migration to move their virtual machines again? That's about the response I typically see. No, nobody wants to put up their hand for that. By default, if you pause a host, so you're doing cluster-aware updating or some unplanned maintenance because of hardware failure or something, we can pause that host and every virtual machine moves using live migration, which is great. Even better if you've got hardware offloads through RDMA and you can get those virtual machines moving really, really quickly. But we can use a cluster property called moveTypeThreshold. And we can specify which virtual machines are moved using live migration, and therefore which virtual machines are moved using quick migration. And why would we do that? Well, we might say we want to make sure only the medium and high virtual machines move using live migrations because we have a lot of virtual machines and we want to save that bandwidth for those high value machines. The low value virtual machines will use or move using quick migration. Basically have their state saved to the shared storage, moved over, and have their state read back in again so they're offline during that move. So we can do that on a cluster-wide basis using moveTypeThreshold, or we can do it on a per virtual machine basis using default move type. So by default, that's a -1 value and inherits the cluster property from moveTypeThreshold. If you want, you can configure a virtual machine to move using live migration, so a value of 1 or 4, or quick migration using a value of 1. Again, we can do all this using PowerShell. So if you've got a cluster of lots and lots of virtual machines, sure, you can go in there and start right-clicking and all that good stuff, but you'll probably want to do it using PowerShell because it's going to be a lot quicker. And this is where PowerShell really starts to come in useful when it's the first time or when you haven't used it before, is performing widespread configuration changes. So we can get the cluster group for a virtual machine, and edit the priority value and set that to 3000 to set it to be a high priority virtual machine. If we want, we can configure the move type threshold and raise it from its default value of 1000. So virtual machines of 1000 or higher are moved using live migration by default. I can raise that value from 1000 to 2000. So now my mediums and highs move using live migration when I pause a host, and my lows will move using quick migration. Or I can configure a particular virtual machine and set its default move type, like so. So let's have a look at this one in action. And you're going to see some live migration running across 20 gig of bandwidth with RDMA. So these virtual machines, assuming the demo gods are kind, are going to move really, really quickly. So let's start this. Open up failover clustering in the background so we can see what's going on. Now we need to see more of failover clustering. Thank you very much. Screen res is a little low. There we go. So now we can see all my virtual machines, and they have a priority of 2000 or medium. And let's actually show more of these virtual machines so we can see what's going on here. There we go. So we're going to configure some of these virtual machines to have a value of 1000 or low. So we do that using PowerShell, nice and quick, a lot quicker than actually going right-click and changing the priority with the mouse. And it does my wrist a lot better too. So now we'll configure some virtual machines with a value of 3000 or high. So we've got a few higher priority virtual machines. Now I'm going to pause the host that they're running on, demo host 1. And this is going to trigger a live migration. You're going to see 10 virtual machines live migrating at the same time. We're using SMB live migration, introduced with Windows Server 2012 or 2, so it's taking advantage of SMB multi-channel, so it's spanning two 10 gig NICs. Those NICs are iWarp, so I've got remote direct memory access, so I've got low CPU impact and low latency. So those virtual machines have just moved like that from host 1 to host 2. And you also saw queued live migration and parallel live migration in action. Now, let's change the move type threshold from 1000 to 2000. This will mean that any low priority virtual machine should move when we do a pause action or an on-pause action using quick migration. Now my bandwidth is reserved for those medium and high priority virtual machines. Now we can see the low priority virtual machines saving their state, moving over, and restoring their state. And we can see the mediums and highs moved using live migration. And that's virtual machine priority in action. And SMB live migration, which, let's face it, is cool. Well, for us nerds. We want to also make sure that our services can survive some sort of failure. Let's face it, we're in IT. Our business in IT is not to provide servers, switches, networks, and storage. Our business is to enable services. The business does not care if some switch is offline or some host is offline. What they care about is their CRM is offline. The thing that creates profit, that enables business operations, that's offline. We typically implement, as I said earlier, clustering to give our infrastructure high availability. But we also need to implement high availability within our services. Because let's face it, hosts fail. And if I have some virtual machine running on host 1, and host 1 fails, that virtual machine is offline while it's failed over and starts up again. And that's lost money to the business. And that's my boss's boss screaming at me and calling me all sorts of rude things over the phone. Or, hopefully not, they're coming down to my desk and screaming down my neck. And I don't want that. There's enough stress in life without having that sort of thing. So we can engineer solutions at the guest OS layer and implement solutions to enforce the concept of fault domains, which you may be familiar with in other virtualization products and in the cloud. We have the ability in Hyper-V and failover clustering to implement anti-affinity. It's not that obvious. It's pretty much buried in PowerShell. If you're running Virtual Machine Manager, you'll know this as another name, and it is kind of obvious there. But we can implement this in Hyper-V and failover clustering using PowerShell. So we can implement either load balancing or guest failover clustering for our virtual machines. I might have a pair of load balanced web servers, and these are how I'm selling product to my customer and generating profit for my business and keeping me as an IT pro employed. I can associate these two machines together as an anti-affinity set. Now failover clustering will do its best to ensure that each of these virtual machines is placed onto a different host. So if one of these hosts fails, yes, that virtual machine will stop running, fail over, and automatically start up, but the other one's still running and still processing work from the customer. And I could implement this with domain controllers, web servers, virtual clusters that are using shared VHDX, and other such features as well, to keep my services highly available and not just my clustered hosts. This is all implemented using PowerShell if you don't have System Center. And some interesting PowerShell. So we'll create a string collection, and using that we might label our service. Then we'll use that label and tag the cluster groups of our virtual machines with that label. So we're editing a property called anti-affinity class names. So I have two virtual machines, VMO1 and VMO2. I tag them both with the same string collection value. And now they are in the same anti-affinity set. So failover clustering will do its best when it's placing these virtual machines on nodes in the cluster. It will do its best to put them onto different nodes, assuming that there's capacity for that. And we can see this in action in a demonstration. So this is the lucky 13 of demonstrations. So we're going to be working with two virtual machines called Affinity 1 and Affinity 2 that you'll be able to see at the top of Failover Cluster Manager there. They are both operating on demo host 1. And these virtual machines are running my web service that I sell product to my customers or my partners or whatever, and they are my business. And in turn, they keep me employed. What I'm going to do is ensure that they are placed onto different hosts by putting them in the same anti-affinity set. So we create a group using a string collection. I'm going to call that my HA service. And then I'm going to join those two virtual machines to that, so editing the cluster groups of those virtual machines, the anti-affinity class names value, and setting it to the result of my new string collection object. Now I can have a look to see who's in that anti-affinity set. And we can see the two virtual machines, anti-affinity 1, or Affinity 1 and Affinity 2, are in that set. And if we go back to failover clustering, we should, nothing's happened. Because it only implements anti-affinity when it's placing the virtual machines. So what I'm going to do is a little trick to trigger that to happen. I'm going to pause another host in the cluster and then resume it. And the cluster is going to evaluate virtual machine placement and trigger anti-affinity for those two virtual machines. So pause the other node in the cluster, resume it, and we can see a live migration has taken place, and Affinity 2 is now running on demo host 2. And now I have a highly available service, not just highly available cluster nodes. And that should keep me employed, hopefully. We'll see. We want to be able to automate, scale out, simplify, speed up, reduce errors, and produce repeatable results. That's what I said when I was building my demos for this presentation. I needed something that I wasn't going to fat finger. I wanted to guarantee that when 60 seconds passed, you saw those alerts for minimum IOPS. I wanted to get the same result every time. When I did cluster schedule tasks, I wanted Notepad to appear exactly 30 seconds after I scheduled the task to run. So I wanted you to see the same thing over and over. And typically, that's what you as an IT pro want as well. And this is why I find it interesting that some people choose to limit their earning potential and the length of their careers by not learning PowerShell. I use PowerShell for all my demos because I got guaranteed results. I'm able to scale out change. If I want to change the switch connection of my virtual machines, single command it, get it done across all my virtual machines. My wrist doesn't get arthritis. I can do more in less time. If I want to deploy lots of virtual machines in Azure or on Hyper-V, PowerShell commandlets, create nice loop, lots of virtual machines while I go off and have my lunch. Or put my feet up and read, some nice MSDN blog and learn more about new stuff. My opinion, not learning PowerShell is a fatal career mistake. But as we saw earlier, almost every hand went up in this room, and you guys are all converts, so I'm just preaching to the choir. There's lots more. Lots more. We could talk about automatic virtual machine activation, so we simplify the licensing of our hosts running on the Data Center Edition. PA ping when we're working with MVGRE. Guest application monitoring to automatically restart our services or move virtual machines around when we have dodgy services in our guest OS. Or even using deduplication to improve the disk utilization of non-pooled VDI virtual machines. There's lots of sessions this week. Please check them out. There's a brilliant run running on Thursday at 12:05. Some Irish guy is going to be talking about using Azure Site Recovery for Hyper-V in small, medium enterprises. So please check that out. There's going to be some interesting sessions this week as well by the Hyper-V team, so check out what Taylor Brown's doing on containers and what Ben Armstrong and Sarah Cooley are doing with the next version of Windows Server Hyper-V. And yes, absolutely check out that storage quality of service presentation that Jose and Senthil are running. Please submit your feedback. I'm going to ask that you put in comments as well, whether they're good or bad. I did tweak this presentation based on bad feedback from before. So scan the QR code. I'd love to hear the feedback, good and bad. Have a great night. Have a great rest of Ignite, and hopefully see you soon.